here that. So the aim of the panel is to look at building an AI safety landscape, perspectives and future work. So do we have any questions for the panel here or Victoria in London?
So Vika, so DeepMind has this sort of agenda / landscape they've put together, that you've put together with them. Question is, I know that there was some statement to the effect that it is not necessarily a complete account of the safety landscape. Is there work or planned work on expanding that, that landscape?
I think there currently isn't a plan to extend it. I assume you're talking about the taxonomy I just discussed, right? The
yes.
Specification, robustness, assurance one. Yeah, I think it wasn't really intended as a really complete landscape. So yeah, I'm happy that you're working on, you know, a really complete landscape for safety. But I think, yeah, the specification, robustness, and assurance landscape was kind of intended to be like a generally useful breakdown of the problems, but it wasn't meant to be comprehensive, as far as I can remember. Mm-hmm.
Okay.
Question here.
This is a question for Victoria also. I was wondering of the different areas of research you were describing, which you think is the most difficult one? Which do you think will be the most difficult for us to address that is necessary to address, if any of them are necessary to address?
Do you mean like the three, which of the three categories is the most difficult?
Yeah.
Yeah, I think, yeah, this is a bit hard to say. I mean, like, part of the reason that I personally work on specification is that it feels like, in some sense, the most difficult part of the problem, although I think robustness and assurance are also, you know, can be quite difficult as well. I mean, partly also is motivated by like some of the specification side being a bit more neglected, since there's more people working on robustness and things like interpretability and so on. And yeah, I think some of my kind of motivation in this is that like Goodhart's law seems really hard, and we are thinking about various ways to overcome different types of Goodhart's law, but yeah, this seems like a bit more difficult to, you know, to get around and to find some sort of complete solutions to these things. Like one nice thing about problems in the robustness category is that like we can expect at least some of them to maybe get easier as the agent becomes more advanced. Like to build an agent that's, you know, really capable, then if there are some things like, you know, unsafe exploration that are bad for the agent that will figure out how to not do that. So because those kinds of problems actually like reduce the utility for the agent. But if you look at specification problems, then you know, if the agent is not being penalized for, you know, for side effects, then it has no incentive to like learn to avoid side effects no matter how capable it is, because it's just not in its incentive structure. So designing the incentive structure seems like, in some sense, the kind of a more difficult part of the problem. But yeah, this is sort of my current view. But yeah, I'm not sure which of these problems will actually end up kind of being the hardest to solve.
Okay, thank you. Do any of the panelists want to comment on that, or should we move to the next question? Do you want to comment, Sean?
What I'd like to do is ask a follow-up question to Victoria on this, which is the you had a nice call to arms at the end of your talk that obviously you've made some very valuable and interesting progress on these problems and on developing kind of general frameworks for thinking about safety problems, but you pointed out there are a lot of opportunities for more work, and these are things that people in this room and elsewhere can help with. Do you have thoughts on areas where you recognize that they're important, but for example, the team you're working with at the moment doesn't necessarily have the backgrounds? Are there areas where we need to bring in more expertise on these problems that people who are coming to hÉigeartaigh should be thinking about and getting involved on?
That is, yeah, I think that's an excellent question. So let's see. Like one such area that comes to mind is maybe like AI boxing or containment, because it's something that like, you know, there's maybe a bit of work going on this in my team, but not that much. And so, yeah, this is something maybe I'd want more people to be working on. I think also just like different angles at the same problems would also be useful, like even things that are like getting a bit more attention. So maybe, like for example, thinking about interpretability, like specifically from the perspective of like advanced agents, because like most of the current work on interpretability focuses on the agents we have now, and on specific applications. So like maybe a bit more of a long-term focus on that problem would be quite useful as well. Yeah, these are just some examples. Yeah, let's see, anything else? I guess right now, in terms of kind of the landscape of safety approaches, there's still kind of a bit of a separation between the sort of machine learning focused safety approaches and things like the MIRI Agent Foundation's agenda. So I occasionally have it in the back of my mind that like it would be good to sort of find some kind of bridge between those perspectives a bit more. And I think people have tried before, and it hasn't been always an easy thing to do, but there's kind of vague sense that there's some kind of gap that needs to be filled. Sorry, this is a bit vague, but yeah, if anything else comes to mind on this question, I will add on that.
Okay, thanks for that. Sorry, question, please.
So I have two questions. One, I'm wondering what your thoughts are on naive AI boxing. It seems to me that if you're just trying to box an AI, then you've already kind of lost, because AI boxing isn't changing the incentive structures of the agent. So I'm wondering what your thoughts are on like why we might want to or not want to pursue that direction.
So I couldn't quite hear that. Can one of the organizers repeat the question into a mic?
Essentially, views on AI boxing. Do we need to do that?
Yeah, the question was basically, haven't we already lost by the time we would actually really, really need that?
Yeah, I mean, in a sense, you could say that like what you really need to do is like align all the agents' incentives, and then you would not need a box. And I think there's a sense in which that's true. But also like while we are kind of building the agent and like still figuring out what incentives it should have, I think like it would be useful to have these kind of containment measures. Like I agree that they're not like the final solution. If you really build like a really advanced superintelligence, then like your box will probably stop working eventually. But yeah, it's a kind of intermediate measure that still seems useful. I guess like part of designing a good AI box could also be like figuring out how to like incentivize the agent not to leave the box. So I think at the end all of these things are related. But yeah, I agree that like maybe it might not be like kind of clearly necessary if you really figured out the incentives well.
Thanks. Now, that was the second question, but do the other members of the panel have a view on that before we go on to the second question?
I can't hear you guys right now.
No. Okay. You've given a complete answer, clearly. So, second question. Thanks.
So, I'm wondering, I was hoping you could expand a bit more on the Offswitch slide. Is there any way we could bring that up in the PowerPoint, the Offswitch environment?
Okay, go on, Richard.
Can you expand on the off switch? Can you bring up the slide and expand on that?
And maybe you can't.
The question was, can you expand on the off-switch problem, and can you bring up the slide on that?
Okay. Yeah, sorry, my sound cut out for a bit.
Victoria, to clarify, I was asking a quick question. It seems to me like there's multiple ways of viewing the problem, where like if you pretend that actually the blinking box is the agent has a 50% chance of falling down the stairs, then according to safe exploration, we actually never want the agent to make the mistake of not, disabling the off switch and making it through the level. So I'm like wondering, I don't know, I just feel confused like what the incentive structure or like what it's trying to test for.
Yeah, one sec. So yeah, it's definitely true that like in some sense this grid world is underspecified because I mean that's kind of a problem that I have with it as well, in the sense that like what makes this a correct incentive structure not to just disable the interruption tile is that it's a signal from the human. While if it was just a bad state where the agent gets stuck, then the agent should disable it. So really, like, what we need for the off-switch problem to be solved is like we need some kind of like channel of information from the human that cannot be corrupted, which is of course not very easy to set up. But yeah, I mean, this grid world is in some sense so simple that you can't really indicate what comes from the human and what doesn't. And so like, yeah, there is definitely like kind of a trade-off between being interruptible and like actually learning to avoid bad states. So yeah, I think we have found that like off-policy agents are interruptible and on-policy agents are not interruptible. And I think this also means that like off-policy agents are not as good at like learning to avoid this kind of state if it's bad. So I think like really to be able to properly test for this kind of problem, we would need to be able to add to the environment some kind of indication that the signal comes from the human and the signal doesn't. Like this state is just a bad state in the environment, and the state is something that's caused by the human, and so it should be treated differently. Yeah, I think it's one of the things that like I think it needs to be worked out. Like how can we distinguish between a human signal and just like bad environment state? How do we make sure that the agent, does not somehow manipulate the human signal? So yeah, still a lot to think about here.
Right, so if that wasn't clear, what are the first steps you need to take in moving beyond the good world into something more complicated? You're applying reinforcement learning somewhere you don't necessarily know all the actions and all the states. Is that right?
Yeah.
Good. Go on, Richard. You're bound to have an opinion.
So, when we talk about safety, which is why we're looking at grid worlds here, it's a lot harder when we don't know the full range of states. There is work to make RL more predictable in the real world, but with there's some work by OpenAI and others trying to do things like data augmentation, adding some sort of jitter to various kinds of data to make this training more robust, so it would actually perform better in the real world. But generally, that work is with respect to translating from simulations to the real world. But if you're talking about where the states are really unknown, then, I mean, yeah, the next steps I would say would be to have more of those sort of open world contexts within simulations before going out into the real world, with the combination of the differences between simulations and the real world and the open world assumptions themselves. So I would say that would be the actual next step.
Thank you. Any other comments?
I guess one thing I would say about grid worlds is that there's also, I mean, of course they are very simple, but the simplicity is also an advantage in the sense that we can isolate a specific problem and test for it directly, sort of like a unit test. Of course, passing the unit test doesn't mean that the system is safe, but you kind of want to make sure it passes the unit test. So, because if you are testing a more complicated agent in a more complicated environment, then failure might not be due to what you think is causing the failure. So it might be some other like implementation problem or like problem of learning the reward function correctly or whatever. So it's easier to isolate the causes of failure on simple environments. But of course, simple environments in themselves are not sufficient, and we do need to build more complex environments as well to test for the same things. But it's good to have both.
And of course, there are dimensions like partial observability or stochasticity or just higher granularity of the space. Like, so obviously things like Dota or even Atari are kind of fine-grained as compared to like grid worlds. But yeah, so there are many such harnesses that we can look at when doing various kinds of testing for generality or for safety. But yeah, specific properties we're keeping in mind, particular types of algorithms.
Thanks, Richard. So,
yeah, I just had a glib version of the answer. This is that the next steps that we would need to take in order to study safety problems in more complex environments would be to have convincing solutions to the grid problems. I think like they're difficult enough as is.
Interesting. So in case people couldn't hear that, the comment was actually you need to have convincing solutions in the grid worlds first before you should proceed beyond that. Okay. So, ladies and gentlemen, other questions? I know it's been a long 2 days, but we haven't solved all the problems yet. There must be still some questions.
Shall we return to the topic of the panel?
Surely not. So the topic of the panel is meant to be building an AI safety landscape, perspectives and future work. Actually, you're sure I've got that picture I emailed you in a way you could actually display it.
If you give me a minute, we struggle a little with internet, but I may be able to actually get it now if you give me a second. While we're trying to load this, I thought one way to kind of get our thoughts going on this a little bit is try and reflect a little on what we've heard over the last while. And for me, I feel like I've heard
several things coming through quite clearly in some areas where I think we, still have a lot of things to work through. I mean, one was the question of gaining consensus around various of these things. It's come up that we mean different things when we use different worlds. There are some issues in terms of like what we mean by certain terminology and what we consider to be important that we will need to have some sort of consensus on in order to be able to work together. But there will be other areas in which it's more of a matter of understanding what we're all speaking about rather than necessarily agreeing on absolutely everything. I've heard a lot of things said about different forms of connections we need in terms of building a landscape. So that includes connecting between safety engineering and work on the cutting edge of fundamental research, connecting between people working on the regulatory, legal and policy side of safety and people on the research and engineering side, making sure that expertise is available and embedded in these areas. There's been a lot on connecting between disciplines that are relevant to safety, some of which aren't maybe represented as well in some domains as they might be. So in the safety engineering field, there was a call for more machine learning people. There have been calls for more expertise coming from cognitive science, from neuroscience, as well as, well, a range of other things I'm probably not thinking of on the spot. There's been some discussion about connecting between some of the very kind of present day practical issues we're dealing with some more long-term focused work, both in terms of getting a better sense of what's coming down the pipeline and how we should prepare for that, and finding ways to turn more abstract longer-term questions into concrete, practical, well-defined issues that communities who are working on these practical issues can engage with. And we briefly touched on the issue of connecting worldwide. We're lucky to be organising this conference in Macau, and increasingly a lot of the leading research in AI is happening in Asia. And we've heard fascinating work on technical safety approaches, regulatory approaches and ethical principle approaches being developed by leading groups such as Tencent. And all of this points to a lot of work that we can do in terms of bringing people together and sharing expertise, all of which I think points to a lot that we can do in terms of developing a landscape. This isn't even touching on a lot of what came up earlier today in the ethical space. Hopefully when this comes up, we'll have a diagram of the huge range of ethical principle documents that have been developed, and the level of kind of coalescing around some key issues, but the areas of disagreement. So that's just like a little bit of a recap of what I've been hearing, what I've been reflecting on, and I'd be very interested in anyone's questions or comments on if any glaring issues have come up that really this community needs to start engaging with more, or that should be the focus for future workshops, or that represent clear next steps to develop a coherent and inclusive landscape of safety research.
I actually also, since we're talking about things that came up over and over again, I think that since we're making calls for experts, I think it was Xiaowei that said this morning that even to properly give specifications, we need formal languages to be able to encode them, and we already lack that. So I would like to make a call for formal mathematicians to join this community a bit more. And another thing that I think came up a lot, and especially today in the talks about ethics, is that we talk a lot about safety before deployment, but once these systems that actually interact with the environment are deployed, a lot of the times they are used in unintended ways, or we have consequences that we don't anticipate because we don't have perfect models of the world. So I think that a lot of future work also should look at the possibilities of long-term monitoring of these unintended effects after deployment.
One other quick comment. I'm aware that we might be losing Victoria fairly soon because of your time limit. I wonder, Victoria, if you might be able to offer a quick comment. It occurs to me that this community in this room, most of us probably weren't at the excellent workshop that you organised along with others at ICLR, which was on safe machine learning. And I wonder if you have any key takeaways from that workshop that people in this community should be thinking about, because clearly these are complementary initiatives.
Yeah, let's see. I guess in terms of takeaways from that workshop, one thing that that workshop was focused on is particularly was bringing together kind of near-term and long-term safety expertise and seeing if there are any like useful overlaps between those different kinds of problems. And yeah, so that's the one thing that came up there is something I've already mentioned in my talk, which is like interpretability is sort of universally useful. So it's something that connects with a lot of other safety problems and kind of makes other safety problems easier. And in some sense, it's kind of an obvious point, but it's also good to be aware of. That's something I actually gave a talk at Murips about a couple of years ago with how different kinds of interpretability that would be useful for different problems in the long-term safety space. So yeah, apart from that, like we had, if you recall, we had a panel on overlaps between long-term and near-term. And I think one thing that came up there is that like, even if there are some overlaps between near and long-term safety problems, we might still be looking for somewhat different solutions, because for long-term problems, we're particularly looking for general solutions that are likely to scale to really advanced systems. Well, people who are solving present-day problems for present-day systems don't have to kind of constrain their solutions in that way. But there are still kind of some sort of common points that could be useful to explore. So for example, like we've been doing this like causal analysis of incentives for long-term problems like reward tampering, and this has some overlap with some of the work on that causal fairness that has been going on, where we also kind of make sort of causal diagrams of the whole setup and see if there's an incentive to observe some protected variable or not. So I think there's like some of the methodology has, you know, some overlap between these problems. And so like this is something that I know a couple of people are exploring. So this is just an example. So yeah, so I think I'm losing track a bit of the original question. Yes, takeaways from the workshop. Yeah, I'm not sure if anything else comes to mind at the moment. I think the main takeaway I would say is like to kind of keep looking at sort of points of overlap between those different fields, because one good thing about near-term safety is that it's a more explored area, like a lot of people have worked in it. And there's more established theory about some of these problems, and so that's something that we in the long-term safety field draw on that's useful for us, because the long-term safety field is smaller and like we don't have that many people and they can't work on everything. Like for example, in my work on side effects, it's been useful to like draw on some of the large body of work that's been done on safe exploration, like even though it's not the same problem, but it's a similar problem in some ways, and it's been really useful to see what people have been able to do in that space. So I think this applies to some of the other overlaps as well. Like, there's some kind of like, you know, wisdom and established theory that has been kind of developed in near-term safety, and we should make sure to use it. And like this goes not just for near-term safety, but for like machine learning in general. So like for the causal analysis stuff, we've been looking into all this stuff, literature on causality, so there's a lot of theory behind it. So kind of the more we can rely on other parts of the field that are more established to like make long-term safety approaches kind of more rigorous, then the better.
Thank you, Vika. I would like to add that I think using those causal influence diagrams is actually quite useful, not only for the internals of the algorithms, but even for the environment surrounding the algorithms. Like, one can sort of model even like what happened in creating filter bubbles on Facebook in 2016 and before then, as modeling the influences that actually had, you know, some rather unsafe consequences for us. So I would say that should be an open area to look at using those more broadly. Going back to expanding the circle we're talking about, or the type of people we're speaking with here, I would say product managers can be quite important if we're talking about employing AI or advanced AI in real-world systems. So having technical product managers entering the loop in these conversations, having them understand and having them act as, I mean, they already effectively act as gatekeepers as to what goes into their products or do not. So they should understand these important types of new gates to include in their repertoires.
Thank you. Thanks very much to Andrea and to Richard for those comments. Whilst we've been talking, Seán has pulled up again this tentative landscape and the categories, and I say that the focus we were meant to talk about is actually how we see taking this forward. Can we actually get some consensus on the structure and do useful things with this? Oh, that's interesting. Full size. Right, and so, I mean, this, you know, unfortunately Huáscar can't be here because I think he was the one who's really driving these ideas, and you know, you can clearly see some of what, you know, Richard was explaining in the work that Future Life had done in this, and you know, things like verification and validation. I think we all sector is important, but I mean, do people see this as being useful structure around which we could build? Is it general enough but also specific enough we can actually say things about the different areas? So what do people think, either from the audience or from the panel?
I think it is a start, one of many independent starts, and bringing those together requires some work.
Huáscar to say something? You have been very late, but still, you have a few minutes.
Okay, good afternoon. I just arrived
Hello.
from Shanghai. Nice to hear you, to see a lot of people here. So maybe just to mention a little bit of how we got this structure, because actually we worked in other existing structures already, and one from Future Lab Institute was something that helped us also to structure this. Okay, and then there is also this body of knowledge from the international program for assuring autonomy in UK, which also considers some things here. For instance, I think that many of this roadmap of structure didn't think about certification. But if we are talking about safety critical system, near or long-term safety critical system based on AI, we should also think in certification to ensure that the system will work in the expected environment. So the question is if how this other initiative like from FREE and maybe from York and how they see the need for process assurance and certification. Have you considered these kind of things in your structure, or should be something that is outside the research scope of your area? So maybe we can go one by one to see if it makes sense, or maybe it doesn't make sense. There are some things here which are match very well with the DeepMind structure as well, but maybe it would be good to hear from them first what they think about the structure or how they should be considered. What it's clear is that this is a high-level structure, of course, but what we expect is to structure better in the future, but at least having something to start discussion. This is the goal.
Sure.
I don't know, do we still have you, Victoria, or are you going?
I think I need to go now. But yeah, thanks everyone for the interesting discussion.
Thank you for joining us.
Thank you very much.
Ramona, would you be able to speak to the DeepMind perspective on this?
Sure. But could you remind me of the question?
So what's your view on this structure, how it relates to the DeepMind paper on these issues?
So I guess one way of framing the question is, I mean, you can slice up these things in various different ways, and it's easy to kind of nitpick on whether one thing falls in one category or another, but there's some bigger questions about, is there something that big that's missing, or is there something kind of fundamentally limiting about framing it this way that might be resolved by framing it in a slightly different way?
Yeah, my opinion, when I first saw it, it seems like the categories have changed a little bit over the course of the day. But it seems to me that the work that we're primarily doing in the technical AISafety team at DeepMind only fits within one or two of the categories, like maybe AISafety foundations, possibly specification and modeling. And the other ones seem much more like different slices of perhaps more near-term concerns. So I guess the thing that seems missing to me is, I don't know, problems that scale and solutions that scale across the development from current AI systems all the way to AGI.
So do you actually think that the stuff about scaling is a separate issue, or is it actually everywhere?
I think it's everywhere, but it's less emphasized by some of the ways that the topics in between have been broken down into individual pieces.
That's an interesting perspective. Thanks.
Roger, do you want to comment? Yes, I think everything's really here. What is maybe missing is that this could be better framed if we think about sectorial aspects. I mean, the same questions don't have the same answers if you consider health devices, electrical devices, or self-driving cars, or nuclear plants. So, the solutions might be quite different, actually. So it's important to keep this in mind as well.
Yeah, I quite understand that perspective, and I agree. I mean, to me, one of the things that shapes this, rather like the question about scale, is how open the environment is, because there are actually some very successful fully autonomous systems, railway trains in Paris and in London and elsewhere, but they operate in very controlled, very closed domains. And the degree of openness, to me, is another really big issue that transcends most of these things. I mean, Huáscar asked about about the Ensuring Autonomy program. I don't think we would break it up quite the same way as this, but I think all the things that are here we think are particularly important. Most of the things we're currently doing actually relate to human-machine interaction, because the level of autonomy of most things so far is that actually there is a level of interaction and actually some huge challenges in that, practical, psychological, as well as more technical issues, I think the runtime monitoring is extremely important, but I see that as being rather long term. At least certainly the enforcement is longer term. We probably need to do some monitoring short term to get some data to understand what we might be able to do in terms of enforcement. So, but yeah, I think broadly that covers the issues that we think matter. I say I wouldn't necessarily structure it this way, but I think we can live with that. Possibly with one other perspective, it depends whether or not you include it in the top box is actually the legal perspective, and we see some challenges in that. For example, if a system makes a decision rather than a person, under civil law, you can't sue them for negligence because the system is not a legal individual. So actually some forms of redress and compensation we would expect to have no longer apply. So there may need to be some changes in law, and people have talked about a sort of tech-neutral change to tort law. It's called the law of negligence if you prefer, which would mean you could actually sue a manufacturer treating the system as an agent of the manufacturer. But I mean, that would be quite a big change to the legal structure that we have. So maybe that needs to sit there somewhere. But to me, law should reflect ethics. It doesn't necessarily, but to me, it probably lives best in the top box. Any other comments? I'm waffling too long.
So I found the last set of comments in particular really fascinating because, I mean, I talked about a few of the themes that came up a little earlier, and I feel like a couple of the themes that came up as well were like the inherent sort of tensions and trade-offs to be navigated when we try to put together some sort of like comprehensive landscape that is inclusive of all the issues that this broader community is thinking about. And I mean, there are three tensions that sort of come through and that I think are somewhat reflected in the diverse set of comments we just had. And one is the tension between very practical real-world safety challenges, for example, in different aspects of safety engineering in a lot of different industries. One is compared to what's happening at the kind of fundamental theoretical research level. Another tension is that between kind of what we're loosely calling kind of present-day or near-term challenges and longer-term challenges. And I'm now blanking on the third one, but it'll come to me. Blame my jet lag, it just kicked in. But it seems to me that it's kind of reflected in how we think about this framework, in that if you're thinking about practical application of AI and the challenges this poses, it's incredibly frustrating to try to limit everything into generalizable challenges across various different places, because all of these things are specific challenges, but they manifest, as Roger pointed out, in quite different ways and to different extents in different industries. And so really what you need is some sort of three-dimensional matrix. And at the same time, if you're thinking about kind of longer term challenges of how we get from here to much more powerful, general, capable systems in the years to come, then kind of lumping all of the kind of challenges that are within that into one little box here, which is safety foundations, doesn't allow you to really get into the range of different challenges there are and the incremental steps that we need to take in order to scale to these general systems. And so it's kind of frustrating from the practical point of view that we have to limit ourselves in that way. It's also frustrating from the kind of long-term perspective that we include such a range of topics in one box. And these are issues that came up in our discussions about this over the course of the last few months. And of course, the issue is if we do try to expand this, we end up with a really vast and very difficult to interrogate and to use matrix of issues. And I think a great effort was made by Richard. You've got this wonderful safety framework with FLI, but there are hundreds of branches and branches of the branches, which is an amazing thing to watch. But even there, if we were considering every industry application, it would rapidly become quite overwhelming. So it comes back to this question of, if we are trying to bring together these efforts and learn from them, we need to recognize that we can't include everything to the depth that we would ideally want to represent them. And I guess the question then becomes, how can we put together some sort of framework that allows us to engage with each other while kind of, including some sort of cutoffs that allow it to remain at least somewhat manageable.
Yeah, absolutely. I couldn't agree more. There are indeed hundreds of nodes that are quite relevant depending on the context. And it's really that context that would create a projection onto this multidimensional space, as you say, which is really a graph of these hundreds of connected nodes. And they're connected in complex ways, not just a tree. And we mentioned this in the first panel discussion of the day. The particular types of connections which would be emphasized in a given context, in a given projection, would really depend on the types of application and domain area and the capabilities of the system, the types of architecture being included, and also whether we're talking about just things of today or given certain assumptions, what types of problems would we expect in the future. So I would say really what we need is a more interactive kind of tool, which would be some sort of multidimensional graph database type thing, which would then be able to automatically generate like a 2D landscape or tree based on answering some number of particular questions on your actual specific context. And this is something I bandied around a bit, specifically with Partnership on AI. We thought maybe we would work on this, but we didn't quite have the resources. But if anybody wants to help us work on this, let this be an open call for people to apply to do that.
I agree with Richard. Actually, having that sort of tool would be extremely useful. That's one of the things we hoped we might do with our body of knowledge in the future. But mechanistically, we don't know how to do it. This is actually, as you say, it's a very complicated, multi-dimensional graph.
I know how to do it. I just don't have the bandwidth.
Well, you can tell me how to do it offline. But ladies and gentlemen, I'm mindful of the time, and some of us need to find our way back to an airport as well, me included. So do we have one or two last questions or comments?
Yeah, I think maybe also in this whole discussion, maybe it would also be interesting to start some kind of an initiative on actually system modeling, because what I also notice is we talk about systems and we talk about all kind of different actually artificial intelligence algorithms, but there are many different types of models, and if people start about system engineering and artificial intelligence and what type of capabilities and functionalities, but everybody has a completely different underlying system model behind it. For example, talking about advanced systems which have metacognition and self-awareness, even this kind of discussion. So if you do not really understand from a system model perspective where actually this type of functionalities kick in, it is from my perspective, very difficult to fit in those type of things. I think from my perspective it can be very helpful also to have some kind of an underlying global system model in which you can also connect the dots. So where do I put security, where is actually my norms, rules, and where actually the algorithms and how do they fit together and how do they interact, would be very helpful, I think, also in structuring the whole discussion.
Yeah, I agree. Yeah, the broader landscape, as you say, should include analyses of norms and sort of ethics and meta-ethics and legal aspects and regulatory aspects. Yeah, completely.
So, question here, and then we can probably draw things to a close.
Okay, so just a quick question. I don't know if that's actually the right one. So when I look at the tentative landscape of categories, I noticed that actually we're looking at the AI safety from single intelligent agent perspective view. Yeah. Should we include also, inter-agent communications, inter-agent, like either multiple agent assistance? Because it's not only one single agent. If we are going to guarantee, for example, in a smart factory, there's a multiple smart agents that interact with each other. Yeah. And meanwhile, you have to guarantee kind of safety, right? So yes. You make one single entity safe doesn't mean you have a group agent, safe agent that is safe. So maybe we should include that perspective as well.
I think that's exactly right. If you have multiple agents interacting, there are a range of additional issues. Actually, that does feature slightly in the body of knowledge, the framework that we have. But we've actually not worked on it as much as we would wish. I mean, like a lot of these things, there are issues about how you cut it up. But I think it is important to factor that out, because as you rightly say, you can have things that individually are safe, but actually collectively aren't, and those sorts of interaction problems and also communication problems that you need to address. But maybe that becomes another layer over the top of this when you're dealing with multi-agent systems. But it's not straightforward at all, and there are lots of problems actually in for example, autonomous driving, where those interactions become a real issue. So, ladies and gentlemen, it's very nearly past when we were due to come to a close. If I may, can I pass over to Huáscar? It's your fault that we're all here, and now you've managed to arrive, which I'm very pleased about. Do you want to say a few closing remarks?
Since I was not at the beginning, I don't know exactly. But just to mention last comment regarding the two last questions, because I think that these are very much related. We need system models, not only system models, but maybe system models. I know that in your initiative you have a generic system models where you have some modules like perception, decision, prediction, etc. So this is the kind of things we need. We cannot, I think we should try to think this as in a multidimensional way. This is just some kind of aspect that should be analyzed by transversally. That could be many other, like as you said, this kind of system. But also, for instance, in AISafety Foundation, what we also thought is about having some kind of levels of autonomy, like in many standards. So there are different aspects that should be considered in order to, as you said, maybe in some fields, in some domains, we don't manage this aspect in the same way. So. What I would really expect from the meeting is to have all this material. I thought you already had a nice discussion, so it's a first step. The idea is to organize other meetings. You also have other initiatives there, and you are asking for some efforts, so we are really willing to work with you or in the body of knowledge, etc. So we would like to join and work. This is the main goal of this meeting. So maybe offline we need to talk about this to avoid dispersion in the work, and then we will see what are really the way of working for the next meeting, or how to do it more concrete. But I think as a first step, it's a great thing to have all these people here to discuss about all these issues. I would like to thank you, all of you, for your effort. Without me, and I expect that we will have another meeting in the future very close. Okay.
Yes, and thank you very much to Huáscar, who was the primary organizer, essentially, of this workshop.